Welcome to What is Heat? Let's start with an illustration. Here we have hot and cold blocks of some material, and they each have a thermometer in them to prove the point. If we put them together, what's going to happen to the temperature of the cold block, and what's going to happen to the temperature of the hot block? Let's take a look. You can see that there has been a transfer of energy from the hot block to the cold block, resulting in the same temperature for each. Heat is a form of energy that flows from one object to another. What kind of energy? That's right, it's the flow of kinetic energy. And it is important to remember that the temperature is the average kinetic energy of a substance, in contrast with heat, which is the flow of kinetic energy. So what direction does heat flow? You're right, always from hot to cold. This is a basic fundamental law of the universe. But how does that happen? What is happening at the particle level? And another interesting question to ponder is, will there still be any heat flow now once the two blocks have reached the same temperature? We will address that question a bit later. So to understand heat, we need to understand how particles are involved in the flow of kinetic energy. Let's back up a bit. Starting with hot and cold again, let's see what's happening between the hot and cold blocks. We'll take a closer look using a magic bus. As we zoom in, you can begin to see the particles that make up the two blocks. The kinetic energy is shown as vibrational motion. The lower block in red has greater vibrational motion. It has a higher average kinetic energy and therefore a higher temperature. The upper block in blue has less vibrational motion. It has a lower temperature. What happens when a slow-moving particle hits a fast-moving particle? There's a transfer of kinetic energy. And how does that affect their temperature? Yes, the cooler particle becomes warm. The hot particle becomes cool. Let's look again as we put the blocks together so the surface particles are in contact. The collisions constantly transfer kinetic energy, which is depicted here with the particles becoming purple and reaching a more intermediate rate of vibration, or in other words, reaching the same temperature. Note they need to transfer kinetic energy both between and within each block for this to happen. Let's get back to a previous important question. Is there any heat transfer now once they have reached the same temperature? Think about it. The atoms are still constantly colliding and so are constantly transferring kinetic energy, but there is no net change in temperature. The two blocks have reached an equilibrium once they reach the same temperature. The amount of heat going from upper block to lower is equal to the amount of heat going from the lower block to the upper block. The rate of kinetic energy transfer between the blocks is now equal, which defines the equilibrium. An important thing to mention is how the surface is being portrayed here, which is as a very smooth, unblemished surface. In reality, at the particle level, we would see an irregular surface with peaks and valleys, where only small localized contact between the two substances would occur and transfer kinetic energy. And yes, these particles are all vibrating. They have kinetic energy, but I will let you use your imagination for that. What is interesting about the gaps is that there are air molecules trapped in them, which we see here. The air molecules will act as an intermediary, colliding with and absorbing kinetic energy from the high kinetic energy hot particles, and then colliding with and transferring that kinetic energy to the slower cold particles and increasing their temperature. Eventually, the two blocks come to the same average kinetic energy, shown here as violet particles. So this video so far has demonstrated one of the three categories of heat, which we call heat conduction, the transfer of heat through the collisions of particles. There is also radiant heat and convection heat, which we will briefly touch on in the next two slides. Radiant heat is energy transfer through electromagnetic radiation, which is light. When photons are absorbed, their energy is transferred to the absorbing body, increasing the kinetic energy of its atoms. And of course, we can't miss this opportunity to show a partial dextro eclipse. Now on to convection, which is heat transfer in fluids. Convection describes the behavior of large aggregates of particles in a fluid, such as air or bodies of water, which does include kinetic energy transfer and other factors as well, depending on temperature differences between aggregates of fluid particles and other conditions within the fluid, all of which is beyond the scope of our video. This has been a Mad Scientist production. See ya.